Alright, so this is our first lesson in Chapter 8, and we're focusing on sequences. So let's go over our learning targets for this lesson. So at the end of this lesson, you will be able to explain in your own words the meaning of the word sequence, term, and inductive definition. Okay? And by the way, you need to write these down in your notes so you have them so you know what the goals were. So when you're studying for your exams or looking back over things, you'll be able to find what you're looking for. All right, next we're going to be able to write and read the notation associated with sequences. By the way, that notation is the inductive definition for the most part, and a few other things, but there's a very special notation that we're going to learn today. We're going to find the first few terms in a sequence using that inductive definition. We're going to suggest inductive definitions when given a sequence, and finally we're going to write a formula for the nth term in a sequence, or of a sequence. Okay, so let's go ahead and get started by talking about what a sequence, term, and inductive definition, what they are. So let's start with the sequence. So you've probably seen this word before because it's something that you guys have been doing since you were probably in second grade. 2, 4, 6, 8. Who do we appreciate all of that? If we were to continue, this is a sequence. It's a pattern of numbers that increases or decreases, in this case, by 2. Okay, we could also have a sequence that's decreasing, so we could start at 20, 15, 10, 5, 0, dot, 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 and continue to go. We could have something that looks like this. Okay, these are all examples of sequences. And basically, sequences are just a pattern of numbers. So these are called arithmetic sequences. Because they're not exponential. So think about if we were to graph these, they'd look like a line. Okay? What separates these from, say, a line is that in this type of math we would call discrete. Okay? These values are discrete. There's not a 2.1 or a 3 or a 3.5. Our sequence goes from 2 to 4. There's nothing in between. So if we were to graph this, what we would see, okay, it's going to be a very bad graph. Okay, we're going to go by 2's here. By 1's here. I'm graphing the first one. Oops. Okay, so my first term has a value of 2, my second term 4, my third term 6, and finally 8. I am not going to draw a line through this because there are no points between the points that I've drawn. These are the only 4 points on the graph, and of course they would extend on. That's what this dot, dot, dot means. Okay, but this is the concept of discreteness in math, is that the only points on the graph, those are the only points in the sequence. So we wouldn't draw a line through these, okay? So that's kind of why this is called an arithmetic sequence. It looks like a line, but there's not a line through it. It just makes a line with the points. So we also need to talk about the word terms. Okay, so a sequence is made up of terms. So this would be term 1, okay, term 2, I'm going to say T2, term 3, term 4, right? 1, 2, 3, 4, 5. There's 5 terms. This one is term 1, term 2, term 3, term 4, term 5. All right? Well, in sequences, we have a way to notate our terms, okay? And the way we do that is terms are notated with a U sub something. And in our textbook, they use the letter R to represent the term number. So R equals the term number, okay? So basically, the U means that they're all variables in a sequence. The R just tells you that they're separate numbers. So this -1 would be U sub 1 because it's the first term, okay? This one would be U sub 2 because it's the second term. U sub 3, U sub 4, U sub 5, And then down the line, I could have, u sub 100, right? If I wanted to. I don't know what that is, but it probably exists in the sequence, okay? So I should not have written this t thing. This is just term 1, term 2, term 3, term 4, which we would write as u sub 1, u sub 2, u sub 3, u sub 4. Oops, u sub 4, okay? And these do need to be true subscripts. Don't write them like u1. That looks like it's a variable times by 1. It's not, okay? It should be u and a 1 underneath, a subscript. That's what the sub is. All right. So let's talk about inductive definitions. Okay? So inductive definitions look different from textbook to textbook. Our variable uses a definition that's different than the definition that we would be using, say, if we were using our advanced algebra book, but they all do the same thing, just maybe they're slightly different from something. So let's start with an increase in sequence. We'll say 1, 3, 5, 7, 9, 11, and then it's going to go on, okay? So the first thing we should notice about this sequence is it increases by 2 the entire way. That's what makes it arithmetic. Okay. All right. So if we're going to write an inductive definition for this arithmetic sequence, we need 2 things. Okay? We have to state the first term, and we have to write a rule. All right? So the first thing we're going to do is, if you remember before we wrote our term numbers, we said u sub 1 equals 1. U sub 2 is 3. U sub 3 is 5, and so on, right? Well, when we're writing inductive definitions, we always start by stating the value of our first term. So we're going to say our first term, this is u sub 1. This means first term equals its value. So in this case, u sub 1 happens to equal 1. Not always the case, it just is here. And I should also put out a side note that we're going to see some real life sequences where we start at u sub 0, so we don't always start at 1, but most of the time. We'll get to that later. Okay, and now we need to write a rule. So our rule really comes in when we have this plus 2. This means our arithmetic sequence is growing by 2 each time. That's the only thing that's happening. Okay, so I'm going to write this, and you need to write this in your notes, and I'll explain it in just a second. Our rule always starts with u sub. This whole thing, r plus 1 is a subscript. Okay, I'll show you why. And in this case, since we're only growing by 2, we have u sub r, and then what we're growing by, plus 2. This is our inductive rule. Let me show you what this means, okay? And I'm going to come up here, okay? So the reason we have to have a first term is because if we don't state that we're starting at 1, we could really start with 100 and go by 2 each time. But if you'll notice this sequence, 100 is not a number in our sequence. So we have to say where we're starting, okay? The other reason we have to say where we're starting is because here's what happens. We know that r is 1. When r is 1, that's this, right? r is 1 here, okay? But what happens is, when r is 1, I can go ahead and say, well, when r is 1, I'm going to put 1 in for r here. And I'm going to put 1 in for r here. I'm doing a substitution because in a sequence, you can only proceed using values that you know. So if I say 1, okay, plus 1 equals u sub 1, okay, plus 2. So let's simplify this. So u sub 1 plus 1. Well, 1 plus 1 is 2. Wow, now this tells me I'm finding the value of term 2, because I have u sub 2 equals something. Okay, well, u sub 1. I know the value of u sub 1. It's 1. So I'm going to substitute 1 in for u sub 1 plus 2, because that's what goes here. That's where I'm getting this right here, equals 3. So that means u sub 2 has a value of 3. Okay? Some books call these recursive formulas because we have to know the term before. Like if I'm trying to find term 2, I have to know term 1 in order to find term 2. If I'm going to find term 10, I have to know term 9 because I have to use it. So subsequent terms until we know the term before. So now that we know term 2, we could come up here and say, well, and I'm just writing when r equals whatever for you guys so you know what I'm doing. So when r equals 2, that means I'm going to take my definition and everywhere I see r, I'm going to put in 2. So I'm going to say u sub 2, okay? The plus 1 stays the same. Plus 1 equals u sub, this is when r equals 2, u sub 2, and then plus 2. Okay, well let's go ahead and sum this. 2 plus 1 is 3, so now I'm finding u sub 3. Well, that means the third term equals the value of u sub 2, which we found right here is 3, so we sub in 3, and then we have our plus 2 that stays. So that means our value of our third term is 5. And we could keep doing this over and over, but what you should have noticed is we went from 1, 3, 5. We know the next terms are going to be 7, 9, 11, 13, 15, and so on. Okay? So let's go ahead and take these definitions and find the first 5 terms in the sequence. Alright? So you don't have to write this whole instruction out, but you should maybe say find first 5 terms, so you know what you're doing in your notes. Okay, so I've lost where I was going there. We'll say we're going to go u sub 1 equals 25, and u sub r plus 1 equals, we're going to say u sub r minus 10. Okay? So we already know our first term. That means u sub 1 is 25. Okay? All this minus 10 is doing is it's basically saying I'm going to take term 1 and I'm going to take away 10. And then I'm going to take that term and take away 10. Basically, it tells us that we're going to keep taking 10 away each time. Okay, so if we did this a long way, we would say u sub 1 plus 1. So this is when r equals 1. Okay, equals u sub 1. So when r equals 1, I'm subbing in 1 here and here for r minus 10. So now I'm finding u sub 2, because 1 plus 1 is 2, and u sub 2 means term 2. U sub 1 is 25. That's a given. Minus 10, that tells me that u sub 2's value is 15. Well, we could keep doing this for 5 terms, or we could notice a pattern. If I'm taking away 10, it means I'm taking 10 away from each new value. So 25 minus 10 is 15. 15 minus 10 is 5. Okay. Our fourth term, u sub 4, I'm going to take away 10 again, so I get negative 5. And finally, our fifth term, taking 10 away, is negative 15. Say u sub 1 equals, say 3. And u sub r plus 1 equals 4 u sub r. Alright, we don't have anything being added, but we have something being multiplied, right? Oh, this is very interesting. So, we're going to start out by saying we know our first term is 3, okay? Well, some of you may know what's going on, but I'm going to show you again when r equals 1, what happens. So basically, that means when r equals 1, I'm going to put 1 in for r here and here. I'm going to say u sub 1 plus 1 equals 4 times u sub 1. Okay? So this basically is u sub 2 equals 4 times. Our value for u sub 1 is 3. Okay? So u sub 2 equals 12. Okay? So what ends up happening here is we're not adding or subtracting anything out here, but we're actually multiplying. So that means that every new value gets multiplied by 4. Kind of like slope, right? Okay? So 12 times 4 is 48. Okay? That means u sub 4 multiplied by 4. 16, 192. I had to make these numbers big tonight. And our last term would be multiplied by 4 again. 768. All right, so there's our first 5.